Well, this is a new section of work, and it's considering polynomial functions. Now, the chapter comes under the heading of Algebra of Polynomials. The first section here in 2.1, we consider what a polynomial function is. You can see we went through this in class, where the notation that we use, we're using these terms here, F, G, H, whatever. It doesn't really matter what letter it is that we use, but quite commonly F is used. And here, instead of writing as we would have done for the last section of work for a straight line, y equals mx plus c, we're using function notation. We replace the y with this. We say it's a function of x, and it equals whatever the function is. This could be, squared. It could be anything at all. So some examples of that are down here, where we could write f of x, the function of x, such that it equals 3x plus 2. We could write p of x, it's still a function of x, any letter we like, equals this here. H of x equals this here. You can think of it in terms of y, but this is just a different way of writing. So this is a function. Another thing that's important too that we introduce here is the idea of independent and dependent variables. Well, what does dependent mean? What does independent mean? Well, in common life, you know what dependence means. It means that you are reliant on something or somebody else. Independent means that you can do things by yourself. You're not depending on anyone. So in maths problems, it's this part here, the function, is the part that's dependent upon something. The value of this is dependent upon whatever value we put x in, whatever value that happens to be. So, for example, if we say, look, let's calculate this for x equals 2. So you would know, you would put x equals 2 into here, and we would end up with 2 3s is 6 plus 2 is 8. So the value of y would be 8, but the value we calculated was dependent upon what value of x we used, and that's the function there. So that's what independent means. Independent. So independent variable, this is the x. The dependent variable is, well, this way it would be the y, but up here it would be whatever the function of x happens to be. Now also, the degree of polynomial is something that's spoken of here. The degree is simply the value of the highest power of x. So in this equation here, this polynomial, the highest power of x is x to the power of 4. So 4 is the degree of this polynomial. For this one here, the highest power of x, there are a few x's, we've got x squared, we've got x cubed. The highest one is x to the power of 3, so it's a degree 3. What about this one? Well, just x by itself, of course, is the same as x to the power of 1. So this has a degree of 1. Let's move on. Now, here we've introduced the idea of like terms and the addition and subtraction of polynomials. Here we see a polynomial defined as px equals x to the power of 4 minus 3x squared plus 4. And here's another one, which we've called q of x is equal to 2x to the power of 4 minus 6x squared plus x minus 3. Here we're asked to add them together and then state the degree of the answer. So here's some students written this here. So here we've written what p of x is, just copying it from here. We've written what q of x is, just copying it from here. And now what we're going to do is add these together. Now here we need to understand what like terms are. So the like terms are where x is involved, other x's that have the same power. You cannot add that and that together. They are two different things. You can try it out by just saying, look, let's make it 3 to the power of 4 plus 3 to the power of 2. Can I add those together to somehow get 3 to the power of 6 or something? Well, if you do the maths, you'll find out that it doesn't work out. If you evaluate that, it will not equal this plus this if you evaluate them out. So that they are not like terms. So here, x to the power of 4, another x to the power of 4, they are like terms. So we can add those two together. 2x plus 4 plus x plus 4 is 3x plus 4. Here we've got two terms which are x squared terms, minus 3x squared, minus 6x squared. Putting those, we can actually add those together to give you minus 9x squared. Notice, despite it's a minus and a minus, we're not multiplying them, so it's take away 3x squared, take away another 3x squared, gives you altogether minus 9x squared. Next we have a 4 here, but just before we do that, we've got here an x to the power of 1, just x. There's no equivalent in here, so it just becomes x, and then we've got 4 and adding minus 3 to it, which just gives us 1. So there's our answer for the adding of them. That's how we do it. It says state the degree. So what's the degree? What's the highest power? The degree for this one is 4. Further down here we now have subtraction. It's really just the same. It's a bit bunched up here where the student's done this, but the same thing. It's qx minus px. They've written it around the other way. So we're taking this one and we're going to subtract this one from it. So here we are going to say, okay, well, it's this one here being taken away from that one. So it's x to the power of 4, and we're going to take that away from here. Would have been better if it was written the other way around, wouldn't it? So we've got 2x minus 4, take away x to the power of 4, just is x to the power of 4. Minus 6x squared minus 3x squared. The minus and minus makes that a plus now, so it's minus 3x squared. X is by itself, and then we've got minus 3, take away 4, minus 7. And the degree, well, again, the highest power is 4, so the degree of it is 4. Should have put brackets around that. So that's how you add or take them away. The next series of problems really are similar to that, adding and taking away these numbers. I don't think I need to really go through these. We've already pretty well discussed that. Number 4, yes, here it talks about a bit of multiplying of functions. So that's f of x plus g of x. Well, f of x is just that, so we've copied that here. G of x is this, but notice it's 2 times g of x, so we have to multiply those functions by 2. So we've got 2x cubed plus, that was 4x squared, 8x squared. And then we just simply add them together as we did previously. So adding these two together leaves us with minus x cubed, adding these two together 4x squared and 5, and so on. So that's the answer to that function, and that was number 1. And then it's just got different scenarios here, having to work this out. Don't need to go through that. Stating the degree. Does this plus this equal that? Asks a question. So we just take f of x here and we add it to itself, get the answer. Then we take that, when we've added f of x there plus f of x there, there's the answer. Then we take f of x, put it here, and multiply it by 2. So here when we multiply by 2, you'll notice that in fact we get the same answer. So therefore we could say, yes, f of x plus f of x does equal 2fx. This problem here, minus f of x, again it's just a matter of saying, well, okay, that is f of x. We just subtract, put the subtraction sign out the front, and when we put that through, that makes that one a plus, it makes that one a minus, it makes that one a minus, so there's your answer. This question here is looking at, it says you've got a function here and another one here. You're told that these numbers here, a, b, c and d, are real numbers, so they're just numbers like 5, 20 or whatever. Then it says, under what conditions are f of t and h of t identical? When does this equal that? What are the conditions that would have to prevail for that to be the case? Well, clearly these numbers here, the a in front of the t cubed, would have to be the same as that. So in other words, a would have to equal 2. b would have to equal that, minus 5, and so on. So if a equals 2, b equals minus 5, c equals 1 there, and d equals 4, then f of t would equal h of t.